The plastic injection mold is a vital component of the injection molding system. The injection mold both determines the shape of the desired part or parts and acts as a heat exchanger to draw heat away from these parts. In addition, the injection mold vents trapped air or gas and ejects the cooled parts. Molds are usually produced from special mold steels, but are also manufactured from materials such as beryllium copper, stainless steel, aluminum, brass, kirksite, and epoxy. Molds are manufactured using a variety of methods, including machining, EDMing, casting, and others. Once manufactured, mold cavities and cores are generally heat-treated. In addition, the cavity and core surfaces are often plated or coated to help resist wear, corrosion, and to aid in part release. As the injection mold is installed in a machine, a locating ring, which seats in a hole in the stationary platen, serves to locate and center the mold. The mold sides are secured by clamps which are screwed into tapped holes covering the platens. Leader pins and bushings align the mold. One pin is asymmetrical to prevent improper assembly. The nozzle of the heating cylinder seats on a sprue bushing which is centered in the locating ring. The sprue bushing has a tapered hole in its center. This directs molten material from the injection machine's nozzle into the mold's runner system or directly into the mold's cavity. A mold's runner system is the channel or channels through which the melted thermoplastic flows to reach the gate. The gate is the interface linking the runners to the cavity which forms the part. If the molten plastic goes directly from the sprue bushing into the part, it is called a sprue gate. Some other gate types that use a runner system include the edge gate, which is the most common, the submarine gate, the tab gate, the ring gate, and the fan gate. Vents are ground on the parting line of the mold to remove the air displaced by the material flowing into it. The size, number, and location of these vents are determined by the molder. They are primarily established by the part geometry, gate location, type of injection material, viscosity of the material, and the rate of injection. Built into the mold are channels for circulating water, which is the mold's primary cooling medium. The water is pumped continuously through the mold to and from a cooling unit, removing the heat and solidifying the part. Proper cooling provides a consistent temperature and coolant flow rate, which contributes to controlled shrinkage, part strength, and other properties. The speed of the injection molding production cycle is controlled by the efficiency of this cooling system. Aside from producing acceptable parts, efficient cooling is the most important factor of the injection molding process. Once the part has had time to cool and solidify, the mold opens at the parting line, which may be flat or regular, or irregular. Since the force of the molten plastic against the mold creates significant friction, a knockout system is required to aid in part ejection. This is usually in the form of knockout pins. In some molds, a sprue puller aids in removing the molded plastic from the sprue. This material can then be reground for reuse. The knockout pins and other mechanisms are mounted between knockout plates, which ride on their own leader pins and bushings in a pocket on the ejection side of the mold. In most cases, they are activated by pneumatic or hydraulic cylinders, although older machines still use mechanical knockouts. Some other types of ejection methods include using a stripper plate, a stripper ring, air ejection, jiggler pins, mechanical cams, cams operated by a hydraulic cylinder, or by a pneumatic cylinder. Over time, Many different mold designs have been developed that meet specific injection molding requirements. These mold designs include the Cold Runner 2-plate mold, the Cold Runner 3-plate mold, the Hot Runner mold, and the Insulated Runner mold. The Cold Runner 2-plate mold consists of 2 plates with the mold cavity and core mounted on them. The Cold Runner system molds the sprue, runners, and gate along with the parts. After ejection, the parts are separated and the rest reground. The Cold Runner 3-plate mold uses 3 plates to mold the part. These plates include the stripper plate, which contains the sprue, the middle or cavity plate, which holds the cavity, runner, and gate, and the movable plate, which holds the molded part. This type of Cold Runner mold design automatically separates the runner system from the part as the mold opens and is very easy to automate. The Hot Runner mold uses an electrically heated manifold that keeps the molten thermoplastic in the runners at the same temperature as the heating cylinder. The heated runner system is contained in a plate of its own and does not open during the molding cycle. Because of this, Hot Runner molds generate no runners or sprues. For this reason, Hot Runner molding, also known as runnerless molding, is fast and efficient. The Insulated Runner mold is much like the Hot Runner mold, but it uses a large diameter runner. During injection, the outer surface of the runner freezes. This insulates the center material, keeping it at the molding temperature.